So hi guys, we're here and we're going to discuss how to solve for a side in right triangles. So first of all, if you're going to solve for a side in right triangles, you should remember or study about the trigonometric ratios, which is the sine, cosine, tangent, secant, cosecant, cotangent. So now we're going to start. For first example, suppose you have triangle, and then one side is 7, then one side is 8, and we have a right triangle. So we all know that we are finding the measurement of the hypotenuse, which is the longest side, and we could remember that in Pythagorean Theorem, the value of hypotenuse is equal to the sum of the square of the two sides. So therefore, we're going to use the Pythagorean Theorem in this example. Then we have, so we should represent hypotenuse with C and the sides with A and B. So now we have C squared is equal to A squared plus B squared. So A is 7 squared plus B is 8 squared. So 7 squared is 49 and 8 squared is 64. And 49 plus 64 is 113. Since we're finding the value of C, which is the hypotenuse, and we have here is C squared, how could we get the value of C? We're just going to square both sides. So we have C is equal to, what is the square root of 113? That is already simplified, therefore we can just write it as square root of 113. Therefore, the value of, or the measurement of, the hypotenuse is square root of 113. Another example of solving a side using the Pythagorean theorem is this. Second, so suppose we have the hypotenuse as 10, then one leg with value of 8. So knowing that the definition of Pythagorean theorem is that the square of hypotenuse is equal to the sum of the square of the two sides, therefore we're going to use that. Represent 10 or the hypotenuse as C, one side as A and one side as B. So again, use the Pythagorean theorem. We have C squared is equal to A squared plus B squared. C is 10, so 10 squared is equal to A as 8 squared plus B squared. Simplify this with 164 plus B squared. So we are going to isolate B squared on the right side, so just going to move this to the left side. And remember, when we're passing the equal sign, the sign of this variable or numerical coefficient should be changed. Therefore, it's 100 minus 64 is equal to B squared. And 100 minus 64 is 36. And that's B squared. So again, to find the value of B, square root. So B is equal to 6. Therefore, the value of this side is 6. So another example is solving for a side in right triangles is using our trigonometric functions, which are the sine, cosine, tangent, cotangent, secant, cosecant. So now, for example, this is our triangle. We have the hypotenuse as 3, one side is 1, and this is the unknown side. And we have a given of a central angle which is 50 degrees. So now we're finding the opposite side in the perception of the 50-degree angle. So we're just going to write here this opposite. And we all know that we have the value of hypotenuse. And we all know that we have a given of hypotenuse, which is the value of 3. So what can we use of a trigonometric function that uses opposite and hypotenuse? It is sine. So we're going to use the sine function. So sine 50 degrees is equal to opposite over hypotenuse, which is 3. So we're going to isolate the opposite in the right side. So we're just going to multiply both sides by 3. Cancel. So we have 3 sine 50 degrees. And now, so solving that using our calculator, measuring 3 sine 50, it's 2.298. So estimate we have 2.30 or 2.3. So our measurement of the opposite is 2.3. So another example, for a fourth example, we have this triangle, and we are now tasked to find this side. And using the perspective of the central angle 50 degrees. So again, we have this value as the hypotenuse, and using the perception of the 50-degree angle, this part is the adjacent. So what trigonometric function uses hypotenuse and adjacent? That is the cosine. So cosine 50 degrees is equal to adjacent over hypotenuse. So substitute our values. We have cosine 50 is equal to adjacent over 6. Multiply both sides by 6. We have 6 cosine 50 is equal to adjacent. And using our calculator, we have 3.856. Simplify, we have 3.86.